Every year it seems like hurricanes are becoming more intense, more destructive, and even more frequent. We've all seen the devastation. Neighborhoods underwater, homes destroyed, and lives changed forever. Maybe you're wondering, what is a hurricane? Why is this happening? Why are hurricanes getting worse? And is there anything that we can do to stop them? First, we should understand what is a hurricane. Can't stop something if we don't know what it is. A hurricane, also known as a tropical cyclone or typhoon in different regions, is a storm system that is rapidly rotating. It's characterized by low pressure center, a closed low-level atmospheric circulation, strong winds, and a spiral arrangement of thunderstorms that produce heavy rains and showers. What does a hurricane look like? Let's talk about the structure. First, it's the eye, the calm center of the hurricane. Typically 20 to 40 miles in diameter, this area is characterized by light winds and clear skies. Second, the eye wall. Surrounding the eye, this is the area of the storm where the most intense winds and rain occur. It's where the storm's energy is concentrated. Third, rain bands. These are long, spiraling bands of thunderstorms that extend outward from the eye wall and produce rain, thunderstorms, and gusty winds. How does a hurricane form? First, warm ocean waters. Hurricanes need warm water that's at least 26.5 degrees Celsius, or for everyone else, 80 degrees Fahrenheit. This heat provides the energy necessary for the storm. Low wind shear allows the storm to build vertically without being disrupted. Additionally, a pre-existing weather disturbance is necessary to initiate the storm. Moisture. High humidity in the atmosphere is crucial for developing the storm formations that make up the storm. Now, there is a connection between hurricanes and ocean swells. So first, let's talk about what are swells. Swells are waves that are generated by distant weather systems and can travel across vast distances of open ocean. They are characterized by their long wavelengths and are often more organized than local wind waves. So how does a swell relate to the hurricane? First, we talk about the generation of swells. As hurricanes develop, they create powerful winds that can generate large swells. The stronger the hurricane, the larger the swell it produces. Now, this is going to have some kind of impact on coastal areas, right? So when hurricanes approach land, the swells they generate can lead to increased wave height and storm surges. This can increase the likelihood of coastal flooding and erosion, but we can use swells as indicators. So observing swells can provide early warning signs of a hurricane's approach. As swells from a developing storm reach the shore, they can indicate the potential for dangerous conditions. Now, there are consequences, right, of swells during a hurricane. First, storm surges. Swells contribute to storm surges. This occurs when the hurricane winds push water towards the shore. This can lead to catastrophic flooding, particularly in areas that are low-lying coastal areas. Creates dangerous surf conditions. Large swells can create hazardous conditions for swimmers and surfers, making beaches unsafe even before the hurricane makes landfall. Why are hurricanes getting worse? First, I think we should understand the different categories or strengths of a hurricane. First, we're looking at a Category 1 hurricane. This is considered a minimal hurricane with winds of 74 to 95 miles per hour and storm surges of 3 to 5 feet. An example of this is Hurricane Hermione, which took place in September 2016 at Alligator Point. Category 2, a moderate hurricane, 96 to 110 miles per hour, storm surges of 6 to 8 feet. And an example of this is Hurricane Sally in September of 2020 on the Gulf Shores. Category 3. An extensive hurricane. Winds of 111 to 130 miles per hour, storm surges of 9 to 12 feet, And an example of this is Hurricane Wilma in 2005, which made landfall on Cape Romano, Category 4, an extreme hurricane. 131 to 155 miles per hour, storm surges of 13 to 18 feet. And an example of this is Hurricane Irma, which is September 2017 and landed in Cujo Key. Category 5, a catastrophic hurricane. This is winds greater than 155 miles per hour, storm surges higher than 18 feet. And an example that recently happened is Hurricane Milton. So what's causing this? First off, climate change. Rising temperature due to increased greenhouse gases from burning fossil fuels is a leading culprit. Warming oceans, because hurricanes thrive on warm water, right? The hotter the ocean, the more energy hurricanes have to strengthen. An example is hurricanes like Milton. This intensified quickly from a tropical storm to a Category 5. The key factors that were driving this intensification were the warmer air and more moisture. Warmer air holds more moisture, leading to heavier rainfall and catastrophic flooding. Hurricanes like Harvey and Hurricane Florence are other examples. Some of these storms are also classified as slower moving. Climate change is causing hurricanes to slowly decrease their speed, which means that they linger over areas longer and in turn dump more rain. More rain and rising temperatures leads to rising sea levels, which also amplifies storm surges and greater coastal damage. So let's talk about those greenhouse gases and global warming. Burning fossil fuels like coal, oil, and gas is warming both the air and the oceans. Now, this is a terrible combination. This terrible combination is what leads to the direct strengthening and frequency increase of hurricanes. Climate change isn't just increasing the intensity, it's making hurricanes larger and slower. Remember, slower means more rain, more flooding, and greater destruction. So can you stop a hurricane? Neither you or I can stop a hurricane. There are things that we can do to reduce their intensity. Hurricanes are natural, but we're making them worse through climate change every day. So we need to start thinking of longer-term solutions to stop this. First, reducing carbon emissions. We need to transition to renewable energy sources like wind, solar, and hydropower. Move away from fossil fuels. Stress the importance of slowing ocean warming. We need to better prepare communities for future hurricanes, like developing a better, more resilient infrastructure. Communities in hurricane-prone areas must invest in infrastructure that can withstand stronger storms. Some examples of this are seawalls, flood-resistant buildings, and even better drainage systems. One thing that should always be worked on is early warning systems. Improved warning systems give people more time to prepare and evacuate, saving lives. These are things that towns and communities can do, but what can we do as an individual? We too can also reduce our carbon footprint. Use less energy, drive less, opt for renewable resources. Some simple steps for us to take are recycling, planting trees, supporting clean energy policies. Every small action counts in the grand scheme of climate change. If you're able to get out and get involved, one way is to support climate-focused leaders and policies. Advocate for corporate responsibility in reducing emissions. Governments must invest in disaster infrastructure and rapid response teams. So remember, hurricanes, they're not stopping anytime soon, and they're unfortunately getting worse, but there is plenty that we can do to reduce their intensity and impact. The fight against climate change is a long, slow battle, but every action counts. So, what will you do to help protect our planet and reduce the risks of these deadly storms? Let's take this challenge seriously and just remember how simple some of the changes are that we could make individually, as a community, and as a world as a whole.